entertain you with some music before we begin. Well, I mean, maybe someone will be able to make music out of this. This is, by the way, available. It's available on the site. It's an early release. So if you wanna look like me, go to there's obviously no ads here yet because it's doesn't work really well. So I'm still trying to improve it. Oops. Should have done that. Yeah, now it's still running in the background. Because if I minimize the window, the camera stops working. So let me know if you tried it, have any questions, and I'll jump straight into the waveform detection using fuzzy logic, trying to detect these different waveforms. Now, so I have those membership functions that as you change the input waveform, you get different activation of the, so we're looking at symmetry of the signal and sharpness. For example, for square, yeah, you have high activation. Triangle, yeah, so that does make sense. Left trapezoid, right, left trapezoid, we're getting something. Yeah, we need a bit more noise in the symbol in the, so we expect sharpness is low, square, so highly symmetrical, so that makes sense. And sharpness is low, that also makes sense. Let's say for trapezoid, let's compare the two. It's also highly symmetrical. It's pretty much, yeah, the same. So based on, also have sharpness is has low activation is high, so meaning it's not very sharp. So it's same as for square, and that's why we're having trouble distinguishing between the two. Expect the sharpness for square to be high, is slightly higher. As you know, we have GPT helping us out. Suggesting looking at the printing the activation levels sounds good. However, is there any option to plot the actual numbers on top of one of the charts? For example, For example, can we overlay these values on top of the symmetry and sharpness membership functions as dots of different colors? Yep. Let's see what it says. Let's turn the volume.
Yes, you can definitely overlay the activation levels on your symmetry and sharpness membership function plots. This visualization will provide a clear, intuitive representation of how the inputs are being interpreted by the fuzzy logic system. Here's a general approach to achieve this using Plotly in JavaScript. Modify the Python backend. Update your Flask backend to send the activation levels to the front end. For instance, include them in the fuzzy_plot_data dictionary that gets returned to the front end. Python copycode fuzzy_plot_data, symmetry, activation_levels, equals low, symmetry_low, mid, symmetry_mid, high, symmetry_high, closing curly bracket, fuzzy_plot_data, sharpness, activation_levels, equals low, sharpness_low,
I'm already doing
mid,
this.
sharpness_mid, high, sharpness_high, closing curly bracket. Update the JavaScript front end. In your JavaScript code, modify the function that plots the membership functions to also plot the activation levels. You will use the data sent from the backend. For example, style the dots. Adjust the size, color, and any other styling attributes of the dots to make them clearly visible and distinguishable on the chart. Refresh and test. After implementing these changes, refresh your front end and test with different inputs to see how the activation levels are represented on the plots.
Yeah.
Remember, this approach requires that the front end and back end are correctly synchronized in terms of data format and structure. Ensure the data sent from the Flask application matches what the JavaScript expects to receive.
Okay, can you check the Python code? We already sending those we're already doing it. Can you find the relevant code? Yep.
To check if your Python backend is already sending the necessary activation level data to the front end, and to find the relevant code, I would typically need to see the specific sections of your Python Flask application code where the fuzzy logic processing and data preparation for the front end are handled. In your Flask route or function that handles the fuzzy logic processing, look for the part of the code that prepares the data to be sent to the front end.
I shouldn't have.
It might look something like this.
But yeah, it should have the clear. Clear. Please check above. You should have the Python code. Let me know if you have trouble finding it. Yep. Yep. It's generating very slowly again.
To confirm if your Python code is sending the necessary activation level data to the front end, I'll review the relevant portions of the Python code you provided earlier in our conversation. Let's check for the section where the fuzzy logic data, including the activation levels, is prepared for the front end.
Yeah, good
From
idea.
the earlier shared Python code, I see the fuzzy_logic function, which calculates and returns the fuzzy logic system's output, fuzzy plot data, and centroid. However, based on the provided snippet, the activation levels for the membership functions, symmetry and sharpness, are not explicitly included in the fuzzy_plot_data that's sent to the front end.
Wait a second. Okay.
Here is a relevant part of your code with comments on where to include the activation levels.
Doesn't make sense. Did we send this already? Yes, we did. I suspect we need to start a new conversation. because it forgot about the code. Should we just update it here? Just upload the fuzzy. Yeah, let's just upload this one. Clear. 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 Oh, come on. We already have that code. Here is the current code that we have. Yep.
Thank you for providing the updated fuzzy_plot_data structure.
Okay.
It's clear now that your Python code is indeed sending the necessary activation level data for both the symmetry and sharpness membership functions to the front end. This data includes the low, mid, and high activation levels for each. Given this setup, you can proceed to plot these activation levels on your membership function charts using Plotly in the front end. Here's an outline of how you can modify your JavaScript to include this data in the plots.
Yes, those should be these two plots. We want to overlay that on top of them. Called it's a plot container. Okay. Right, it seemed to have access to the JavaScript. Clear. So we have the scatter plot. Now we also adding these markers. Symmetry activation trace. The centroid. Symmetry membership function. Symmetry activation trace. We still have the one trace. Let's do this one by one. Get rid of that. Symmetry activation trace. And can comment this out. And we're getting some sort of error. And when we get the error, we'll play some music to relax. Hopefully you find it relaxing. By the way, you can try that in the link in the chat. There's a link to the gesture groove. That's the one I'm using. And it's all running in JavaScript, so I'm not sending any of your video hand applications to my server or anything. It all stays local on your machine. And we're having an error. There's nothing indicating an error. Must be the names. Fuzzy data symmetry activation low. Is that what we are sending? Activation low. Seems legit. Oops. It's the wrong window. Yeah, this one. Let's check the errors again. Let's check the terminal first. The terminal seem okay. Right, because the problem with JavaScript. Of course it is. JavaScript. Never understand. Is it line 101 or 94? Okay. I know. No. Wait, I don't know. You do have the fuzzy data. Do have the fuzzy data. Yeah, it's actually 124, isn't it? 124. Symmetry membership function. Symmetry activation trace. Must be an array. Why? It is an array. Y values are an array. Yeah, I don't want to ask GitHub Copilot because it won't have all the context. Get this. I get this error around this code. That's the error. Let's see what it says.
The error you're encountering, error, grand data must be an array, suggests that there's an issue with the data format being passed to Plotly's add traces function. It's likely that the data structure is not as Plotly expects. In the plot fuzzy logic parameters function, particularly at this line, the issue could be with the structure of symmetry activation trace. Let's inspect and correct it.
How about you correct it? I'll just use the code.
Check the data structure for symmetry activation trace. The Y property in symmetry activation trace is set to an array containing 3 arrays: activation underscore low, activation underscore mid, activation underscore high. However, Plotly expects a single array of values for Y. You need to ensure that each activation level is a single number, not an array, and that they correspond correctly to the X values.
Okay. Don't particularly care how it looks like. Yes, this code is much longer, but I can deal with it. And it's just the symmetry, not the sharpness. Symmetry activation trace. And in Plotly add traces.
Ensure that the element with the ID symmetry membership function already has a Plotly plot rendered in it before you try to add traces to it. If not, you'll need to create the initial plot first. Ensure that the element with the ID symmetry membership function already has a Plotly plot rendered in it before you try to add traces to it. If not, you'll need to create the initial plot first.
What so did I need to do? I need to add this to keep one as well. Yes, looks like. Okay, just bombarded my graph with okay, wait a second. Maybe the original thing gave was correct. Right, seems like it was correct. So the activation, the symmetry activation level. So over there. Right, actually moving around, so this is good. What's the, that's just the red. Symmetry activation, now what's the blue and the green? Symmetry activation. Go figure. Okay, we might have to finish. I started too late today. And yes, we'll have to do more of this monitoring. Yeah, we actually want to get rid of that. Say working well. Right now the questions. There's red, green, blue. Yeah, we need to sort it out later. Might do it next time. So I'll leave you some amazing music. Yeah, if you can sing maybe as well, you can do a lot of TikTok videos or something. I'll add the instructions to it and wrap it up in a proper page. I'll see you later. This is what bye bye sounds. Do it. Bye.